Welcome geometry students, trigonometry students, to section 8.3. We're continuing with inverse trigonometry. You're definitely going to need a calculator, so make sure you have one. They look like this in case you don't know. They got a little screen, they got buttons all over the place. Okay, so make sure you grab one. Make sure we're using degree mode, so make sure you have it in degree mode in case you don't. Okay, so inverse trigonometry, very similar to what we talked about earlier. Okay, if we scroll up, and you follow along with our other notes, we had talked about sine, cosine, and tangent, the definition of the different ratios, how to label the triangle. So let's go ahead and start with that. Okay, we have a triangle given here. We know it's a right triangle, so we can use trigonometry with it. And we have sides of 6 and 10, and we have an unknown angle that we need to find. Now we're trying to find an angle and not a side. Here we had Leaning Tower of Pisa, we were trying to find a side length. Now we're trying to find an angle. That's why it's called inverse. Because instead of finding sides, we are, and I'll write this down, finding angles instead of sides. So just to be clear, trigonometry, okay, so I'll write that over here just so you know. And regular trig, we use that to find sides. Inverse, we use it to find angles instead, okay? Now, the same principles apply. The first thing is don't forget to label reference angle and sides. Okay, it's very important to do that. Okay, that sets up all our trig ratios. So don't forget to label, let me move this up actually. Don't forget to label the reference angle and the sides. So here we have our reference angle. That one's pretty obvious. So this is our reference angle. Okay, so this will help us determine our sides here. So our sides, our hypotenuse is always going to be the same. It's always there, opposite the 90-degree angle. Okay, the opposite side is the one that is not touching the reference angle, and the adjacent side is the one that is touching the reference angle. So there we have it. We have opposite, hypotenuse, and adjacent. So we're kind of ready to get started already. Now, step one, it says write the ratio. So if we're trying to find sine of x, okay, sine of x we know is 6 over 10, okay? Because, let me go ahead and break this down, sine is opposite over hypotenuse. So sine of x is going to be equal to 6 over 10. Okay, we know that because that's our opposite side and there's a hypotenuse. So our opposite side is essentially 60% of the length, 6 out of 10 of the length of the hypotenuse. Step 2, use the inverse. Now, this is a big jump here, but it's something I really want to emphasize. So one thing we can do first is we could go, okay, sine of x is equal to 0.6. Okay, if you want. You don't have to do that. You could leave it as a fraction if you wanted to, but I'm guessing most people like to just type it in as a decimal. So keep in mind, as with any equation, what we want to do is we want to solve for x. We want to solve for our missing side. Over here in this problem, when we had this cosine problem, we're trying to find a side, we were looking for L. We were looking for the variable. We were looking for the missing side. This time, look where it is. We have x next to sine. That means x is an angle. It's a reference angle that we're trying to find and the number of degrees of. So how do we undo this operation? When I say undo, like for example, if we have 2x equals 0.6, we would divide both sides by 2. Why? We would divide because it's the opposite operation of multiplying by 2. So if we multiply by 2, the opposite operation is divide by 2. Well, what's the opposite operation of sine of x? How do we undo a sine? And that is very clearly to inverse sine. So we inverse sine essentially both sides of the equation. Okay, and this looks confusing at first. I promise it's not so bad. So we inverse sine both sides. Why do we do that? Well, we inverse sine because, like I said, it undoes the sine. What are we left with? Just x. Okay, so now we have x by itself because we inversed sine that side of the equal sign. Now what do we have on the right side? Well, now we have inverse sine of 0.6. So we have the inverse sine of 0.6 And now we can use our calculator. This is the part where you're going to need to use the calculator, and that's step 3. Use the calculator. So here we have our calculator. Boom, boom, boom. Make sure it's in degree mode. We use our calculator, and we're just going to type this in. You may have to use the second key. Okay, almost guaranteed you're going to have to use the second key for this. It's probably going to be second and then sine to get the inverse of inverse sine. And inverse sine looks just like this. That's what inverse sine button looks like. So we're going to go, it depends on how your calculator. Some calculators you type in 0.6 first. Mine, I type in inverse sine first, and I type in 0.6. You can even type in 6/10. Both of these are the same. You could do inverse sine of 6 divided by 10 and type that in. Either one works. I'm just going to use decimal because I already had it written. And I hit enter, and I get x equals 36.87, rounded to the nearest hundredth. Now, what does that mean? That is the number of degrees. So that is my answer. I have this x is equal to 87 degrees. So pretty remarkable that we can use inverse trigonometry to help us find the angle of any triangle where we're given at least 2 sides. Also, I want to mention the reason why the calculator works is because it has stored in all the different triangles of any length. Mathematicians discovered that, like I said in the last video, every triangle with 5 degrees has certain properties. So they calculated all these ratios for you, and the calculator can reference those ratios very quickly. So if you're wondering how it works, that is how. Okay, so there's our answer there. Now, technically, we can also use cosine of x. Well, how do we use cosine of x when we don't have that side, the adjacent side? Because keep in mind, cosine is adjacent over hypotenuse. Well, we would need to first find this. So we could use Pythagorean theorem to find that side. Here's C. We could call that A and B. A squared plus B squared equals C squared. And we would find that the adjacent side is 8. Okay, this is a 3, 4, 5 reference triangle. So the adjacent side would be 8. So that is something that you can keep in mind, that we can find the missing adjacent side by using Pythagorean theorem. So technically this is 8/10. Now, we can do the same process here. If cosine of x is equal to 0.8, we can take the inverse cosine. We can take the inverse cosine of both sides. Let me move this over so I can take the inverse cosine. And this undoes the cosine. We're left with x on the left side, and we have cosine, inverse cosine of 0.8. So we go ahead to our calculator. Same process, inverse cosine, 0.8. I hit enter, and I get the same exact thing. So you can get the answer in 2 different ways. I wanted to show that real quickly. So that is the basics of inverse trigonometry. Let's go ahead and example 3, and we're going to finish up. A plane is approaching the runway. Its angle of depression is 7 degrees, and its elevation is 400 meters. How far is it from the control tower? Okay, a couple different things we can do with this one. First, we always want to label and determine what the reference angle is. So we can do a couple things. What I think most people would do is they're going to use this as their reference angle. So let me go ahead and use this as my reference angle. Okay, so this is my reference angle. Reference angle. Okay. X. Then, well, where's my triangle? I need to draw my triangle still. So let me go ahead and show you the triangle I'm going to draw. I'm going to draw this triangle right here. Sorry, a little squiggle. Okay, so there's my triangle. Because this is perpendicular to the ground, that would be an altitude. Okay, so that would be my right angle. Now let's label my sides. This would be my hypotenuse. So I have x here as my hypotenuse. Okay, that's good news. Then I would have, this is my adjacent side. I don't know anything about that. And then I have this as my opposite side. And do I have information on that? Yes, I do. Notice how I have this 400 meters right here. That's my altitude. This altitude is going to be the same on this side, so this is going to be 400 meters. Okay, so done with step 1. Reference. I'm done with my labeling. Step 1, write the ratio. Okay, now I need to determine the ratio. So if you haven't determined the ratio, that's probably a step before that. So what ratio are we going to use? This is similar to when we did this problem in determining our trig ratio. So we need to determine our trig ratio here. First, let's analyze what information we're given. Well, we're given information on our opposite side. We know that's 400 meters. We don't know anything about our adjacent side, nor do we care. The other information we're looking for is our hypotenuse. So we want something that uses our opposite side and our hypotenuse. When you go up here to reference, what side uses opposite and hypotenuse? That would be the sine. The sine uses the opposite and the hypotenuse, so we're going to write a ratio using sine. Okay, so we're going to come down here. We know that the ratio we're going to use now is sine. So the sine of 7 degrees is going to be equal to, opposite side is 400, and our hypotenuse is x. So here we notice that, okay, look at what's missing. We're not using inverse trig. Why? Because we're not trying to determine a side. I didn't even realize this until I wrote the sides. I wasn't even paying attention. But notice we're using trig to find the sides. We're not using inverse trig for this one. Okay, so we're trying to find the side length here, the distance. So it's definitely not inverse trig. We're using regular trigonometry here. So I'm going to put this over 1. And what I'm going to do is I'm going to cross multiply. I have sine of 7 times x equals 400. Now what I'm going to do is I'm just going to solve for x. So I'm going to divide both sides by sine of 7 degrees. Divide by sine of 7 degrees. Okay, and this is going to give me my final answer. So I'm going to take 400 on my calculator divided by parentheses sine of 7. I like to put parentheses just in case. So what I literally typed in my calculator was this. I typed in 400 divided by sine, parentheses, sine of 7, parentheses. Okay, I typed that just to make double check, and I got 3,282.2 meters. 3,282.2 meters. So that's the distance. We didn't use inverse trig for this one. That was a good review from before. Inverse trig, we'd follow the same process, but instead, if it was like sine of x equals 400 over 3,282, we would take the inverse sine of both sides. Okay, so the inverse sine of this essentially to solve for x, and that would give us the number of degrees. Hope you guys like this video. That's trigonometry in a nutshell. Give me a shout out and a comment if you guys need more problems done, or a Khan Academy or some other worksheet. I'll be happy to help. Thanks for watching. See you next time.